Okay guys, so we're going to have a look at paper 2 of the mock question 9 from part 4 onwards. So what this has to do with a roof, and this is the side view of the roof, which is a bit tricky to understand because in the question it tells you the length of the roof is 15. So you've got a length here which is 6, but this is, imagine that we're looking at the side view of your house. So this bit is the arch there, and the roof actually continues on out here for 15 meters. So effectively the roof is actually two rectangles. So it's this rectangle here and the opposite side, another rectangle there, pushed together like that. So the first question asks us to find the total area of the roof. So I've filled in everything we've done in the previous parts. So some of this information was given, some we worked out. This was the height of the roof we worked out, and we worked out this 3.08 there as well. So we're asked to find the total area. Well, this is actually quite an easy question, but it's a little bit confusing because, as I said, this is just two rectangles. So it's a rectangle here and a rectangle behind. So we just need to figure out the area of this rectangle here, the area of the rectangle behind, and then we can work out the area of the roof. So if you look at this one here, what we have is something that looks like that. Okay, we know that it's 3.08 there, and we know that it's 15 long there. And for the second one, over this side, we have a very similar situation, right? We've got 4.5, so we know it's 4.5, and we know it's 15 long. And then two are just put together to give us the roof. So we just need to work out the area of this and the area of this and add them together. So what I'm going to do there is I'm going to do 3.08 times by 15 equals, and I'm going to do 4.5 times by 15 equals. So I do the first one, I get 46.5, second one I get 67.5, add them together and I get 113.7 meters squared. And that's the area of the roof there. So again, it's the wording of the question that's the problem. Okay, figuring out, because it's written that it's 15 meters long, that this is the side view and then it goes out or stretches 15 meters this way. So the second question here, so question 9 part B, this one's very tricky. Okay, it's actually, the maths in it isn't too bad, but it's figuring out what they're asking. So it's got to do with the pitch of the roof. So it says that the pitch of the roof is now equal. If you look there, that is not equal. The pitch of the roof is not equal because that's 4.5 meters there, that's 3.08. So it's saying that they're now the same. So the roof would look, in the side view, something like this. Now, when the pitch is the same, it means it's an isosceles triangle. So, this angle here is going to be the same as this angle here, right? And this side here is going to be the same as this side here. Now, it's not actually asking us to prove that. We can prove it if you want. So, we can say that that's A, that's C, that's B. Well, in order to prove that's an isosceles triangle, what I would know is that AC is going to be equal to BC. We know that because the pitch is the same, so they're going to be the same length up there and up there. We know that this angle here, so I'm going to call it angle CAB. So angle CAB is going to be equal to this angle here, CBA. CBA. And we know that, we'll call this D, that this side here, CD, is common to both those triangles. We know that CD is equal to CD. And if we know that them two triangles are the same, then we know that this length here is the same as this length here. And we're told that the whole length across the roof is 6, that hasn't changed. So this must be 3, and this must be 3. Now this bit here, you're not actually asked to do in the exam. You've proved to yourself, you can just straight off know, if you know that they're going to be the same there, that's a length of 6. In order for each side of the roof to be equal, or the pitch to be same, there's an isosceles triangle, that must be 3 and that must be 3 there. Okay, if you just state that, that's fine, but that's how you prove it. And what it's asking you to do is to find the angle here. So I'm going to redraw this out. So I'm just going to draw out this triangle here. That's A, that's C, that's D. that's 3 there, and we know that's 2.25. We worked out in a previous part of the question. So we're looking for this angle here, and we'll call it x. So we've got a right angle triangle, we're looking for an angle. What we're going to do here is we're going to use SOHCAHTOA. So I'm going to go SOHCAHTOA. Now, I know that this is my hypotenuse, because this is the right angle here, across from this, the biggest side is the hypotenuse. I know that this is my opposite, it's across from the angle there, so that's O, and I know that this is my adjacent here. Okay, so opposite across from the angle, hypotenuse across from the right angle, biggest side, the other side is the adjacent. So, information I have, the adjacent and the opposite. So I'm going to use tan. So I'm going to use tan for this one. And what I'm going to do is I'm just going to bring it over this side here. Okay. And I'm going to write tan is equal to opposite over adjacent. So to figure out the angle, we do tan to the minus 1. And our opposite here is 2.25. And our adjacent is 3. So we put that into our calculator, tan to the minus 1, fraction in brackets 2.25 over 3, and it comes out as, I'll do it now, sorry, I forgot to do that calculation. So, second function, around 2.25 divided by 3. I'm going to 36.8 degrees. So it's 36.8 degrees. Now, B part 2. Again, it's simple enough trigonometry, but looks a lot more difficult. So it gives us this situation now that the roof, as we said, is equal on either side. Here it's not equal, that's 4.5, that's 3.08. This one now is equal on either side, it's an isosceles triangle. So what we're going to do is we're going to figure out the new area of the roof. So we're going to figure out the new area of this rectangle here and the previous, or the backside rectangle. So last time it was easy, you could just multiply the two sides like that, but this time it's a little bit more tricky. Okay, I need to figure out what this side is, because this side has changed. We haven't got the slant height here. We know that this is 3 and this is 3, like we have here. We know that this is 2.25, but we haven't got the actual slant height. So let's just draw out one of these triangles again. So this one here, this is 2.25, this is 3 here. I need to get this slant height here, I'm going to call it x. Well, because I have a right angle triangle and I'm given two sides, I can straight away just start using Pythagoras on this. So I know that x squared is equal to 2.25 squared plus 3 squared. The big side squared is equal to the other two sides squared, added together. So I get x squared is equal to 14.06. Okay, that's them added together. And I need to get the square root of that, so x is equal to the square root of 14.06, or in this case it's 3.75. So x is 3.75. Now, I know that this is 3.75, right? But this roof continues on 15 meters that way. So I'm left with two identical rectangles now. 3.75 there, 15 there, put together to make the roof. So I'm just going to times that together. So I'm going to do 3.75 times by 15. And because I need two of those to make a roof, remember, you need two of them rested together. I'm just going to times my total answer by 2, and I get 112.5 meters squared. And the final part of the question I'm not going to write out asks us to compare the two roof. So it says something along the lines of, what do we notice about the roof when the pitch changes? So basically, the answer to this, and I don't think this will be given an even start, it's a bit of a tricky question, but the area here is actually different to the area here. So the idea is that if you change the pitch of the roof, right, so if you change the slant of the roof, the area can actually change, and it doesn't have to increase, it can decrease. So if you mention anything about the area changing there, you should get full marks.